everyone, in today's video we are going to look at sampling distribution. And so before we get started, for those of you who still maybe aren't very familiar with normal distribution, then I definitely suggest you to go back to one of my previous videos where I focused on going through problems that relates to normal distribution, because in today's video we are doing sampling distribution, which is like a build on from normal distribution. Okay, so let's get started. In sampling distribution, there's sample mean and there's sample proportion. So let's first take a look at sample mean. So before we get started, let's first take a look at the formulas that you need to know. So let's say I have a regular normal distribution with mean and standard deviation. When we have a sample distribution, then the mean would be just the mean by itself. It would be the same, but the standard deviation for a sample would be not just standard deviation. It will be standard deviation over square root of n, which is the sample size. So this is a formula that you want to know, but for those of you who are taking AP Stats, there's a formula sheet that they will provide you on the test, and so you don't need to worry about memorizing this. Just you want to make sure that you know how to make use of this. So now let's take a look at the question. The amount of gas purchased by customers at a gas station averages 12 gallons with a standard deviation of 5 gallons. So when we do sample mean, we always have like a condition where it has to be independent, but here it says assume the condition of random, independent, and normal are met. So therefore we can just go on and we don't need to check the conditions. But normally if they don't provide you this, you want to check the conditions. Okay, so here we have average 12 gallons and standard deviation 5. So let's put that in notation. So 12 gallons and standard deviation of 5. And now it says what is the mean and standard deviation of the amount of gas purchased by the next 100 customers. So by saying 100 customers, it's basically saying a sample. So now we want to look at the sample. So if we take a look at the formula, the mean remains the same, 12. But the standard deviation now is going to be 5 over square root of n. And here n is the sample size, which is 100. And if we put that in calculator, we get 0.5. So basically, the mean of the sample would be 12 gallons. And then the standard deviation of the sample would be 0.5 gallons. So now let's make use of that and find the probability that the next 100 customers average between 11 and 13 gallons. So again, it says 100 customers. That means we're referring to the sample. So then we want to make use of this here. So if we were to, let's just copy that down. We have 12 for the mean and 0.5 for standard deviation. And it says between 11 and 13. So that means we want to use normal CDF. And again, if you're not familiar with how to do this, please refer to my previous video, because that's where I teach about normal CDF. Okay, so it says between 11 and 13, so that means 11 is my lower bound and 13 is my upper bound. And the mean, I just copy it from here, as well as the standard deviation. So if we were to put that in the calculator, I would get around 0.9545, which is basically 95.45%. So what it means is the next 100 customers average purchase between 11 and 13 gallons is around 95.45%, which is very likely. So now let's move on to sample proportion. Again, before we get started, let's first take a look at the formulas that you want to know. So for the mean of a sample proportion, it's going to be the probability. And then for the standard deviation, on the other hand, for a sample proportion, it's going to be square root p times 1 minus p over n, where n is, again, the sample size, and then p is the probability. So that's the formula, and again, it's provided in the formula booklet. Remember, you just want to know how to make use of these formulas. So you can pause the video to read through. So now that you've read through it, basically there are two numbers here that are very important. It says President Obama received 52% of the vote. So that means that's basically 0.52. That's our probability. And then here it also says you conduct an exit poll of 1,000 Pennsylvania voters. So 1,000 is our sample size. So let's write down our mean for a sample proportion. So here it says P, or probability, and it's given here, which is 0.52. And then for the standard deviation for a sample proportion, it's going to be square root of the P, which is probability 0.52, times 1 minus P, which is 0.48, over N, which is 1,000. And if you put that in the calculator, you get around 0.015799. And then here the question is asking, what is the probability that a majority of your sample did not vote for President Obama? So when it says a majority, it basically means 50% or less actually vote for Obama. So if we were to draw that out, we have our mean is 0.52, and around here is 0.5. And here it says probability that a majority of your sample did not vote for President Obama. It's basically saying this area right here, where this is 50% or less people vote for Obama. So now we can use all this and put it in normal CDF to find out. So because it's 50% or less, it's going to be, the lower boundary is negative infinity to 0.5. And then the mean is 0.52 and standard deviation is 0.15799. And then if you put that in the calculator, you get around 0.10277. And so what it means is basically the probability that a majority of my sample did not vote for President Obama is around 10.277% out of the 1,000 people. So that's sample proportion, and I hope this video helps, and I'll see you again next time. Thank you.